In this video, we will learn about measuring the volume of a liquid using a graduated cylinder and a graduated beaker. So to accurately measure the volume of liquid, we can use graduated cylinder or a measuring graduated beaker, which has markings, and these markings allow for precise volume readings. And to understand the measurements, let us perform the following activity. And this activity is used for measuring liquid volumes with a graduate cylinder. So the aim of the activity is to measure the volume of liquid by using a measuring or a graduated cylinder. So the materials required here is measuring a graduated cylinder and the liquid which is to be measured. Now the procedure is, firstly, we have to prepare the graduated cylinder. We have to ensure that the graduated cylinder is clean and dry before use. Now we have to pour the liquid. Carefully pour the liquid into the graduated cylinder until it reaches the desired level. Now we have to observe the meniscus. As we have poured the liquid, now we will notice that the surface of the liquid is slightly curved, and this curved surface is called the meniscus. Now we have to look at the graduate cylinder at eye level, and which is not from the above, this thing, and not from the below, to avoid the parallax error. This is the correct reading. Note the reading at the lower level of the meniscus. This is the correct volume of the liquid in the each cylinder. This is the correct reading. Now, write down the volume measurement for the future reference. Here, one important thing is that ensure your eye is at the same level at the bottom of the meniscus to obtain an accurate reading. This helps to prevent errors in measurement due to the curved surface of the liquid. And from this activity, we can conclude that by using a graduated cylinder, it is an effective way to measure the volume of liquid accurately, and by paying attention to the meniscus and ensuring proper eye level alignment, we can obtain a precise volume readings. Volume of irregular solids. Irregular solids do not have a definite geometry shape, making it difficult to calculate their volume using a standard formulas. However, we can measure the volume of irregular solids by using water displacement method within the measuring cylinder. So, here is an activity for measuring the volume of an irregular solid such as stone piece, and the aim of this activity is to measure the volume of an irregular solid like stone piece. The material required for this activity is measuring cylinder, water, a table, a stone piece, and a thread. So the procedure is, firstly we have to fill the measuring cylinder. Now take the measuring cylinder and fill it half with water. Now we have to note the initial water level. Now we have to place the measuring cylinder on a horizontal surface like table and carefully observe the water meniscus and record the initial reading of the water, that is V1. In milliliters. Now take a small stone piece with the irregular shape and tie it securely to a thread, and carefully immerse the tied stone piece in the water without letting it touch the bottom of the measuring cylinder, and ensures that the stone is fully submerged. And now we have to observe the water meniscus again after immersing the stone and record the final reading, that is V2 in milliliters. And now we can calculate the volume of the stone we can use the formula to calculate this volume of this irregular solid. Now we know that the initial rating of the water meniscus is 50 and the final reading is 70. So the volume of the given stone piece can be calculated, which is V is equals to V2 minus V1, and V2 is 70 and V1 is 50. So the value will be 20 ml. So now this method allows us to accurately determine the volume of irregular solids using the displacement of water in a measuring cylinder, and by measuring the initial and final water levels we can easily calculate the volume of the solid. I hope this topic is clear to you. Thank you.